Yeah, hi. So my name is Minko Gechev. I'm working on Angular at Google, where I lead developer relations and the product roadmap. And today I'm going to share with you kind of a very horizontal overview of what is the state of Angular. We're going to discuss a lot of things, but not necessarily dig too much in depth, since I'm not expecting you all to be Angular developers here. And I see a lot of people are still coming, so maybe we can wait for like a minute or two. Okay. So yeah, I'm pretty excited to be in Portugal. I was for the Portuguese, for Porto. That was my very first favorite soccer, football team as a kid. So I'm happy after 25 years to be able to come here. And in general, this open source community and open source software have been a pretty important part of my career and also my personal life, with opening my very first pull request to AngularJS back in 2013, where I added one missing brace to the documentation. Just only a single line of change, but enabled me eventually to open many more pull requests, eventually join the team, create other open source projects. And thanks to the open source community and Angular, I ended up starting a company in Silicon Valley and transitioned all the way from my hometown to San Francisco. And as you can imagine, my hometown in Bulgaria and San Francisco, they had really different culture. I didn't know anyone, but thanks to organizing meetups of Angular San Francisco, I ended up finding friends with common interests. We were brainstorming how we can make Angular better, how we can move the web forward, and build some friendships. So that's why I'm really happy that after 3 years now, we're now able to go to in-person events and meet each other in person and chat about technology. Wanted to check first, how many of you here are, let's say, know about Angular? Everyone, cool. And how many of you are using Angular? Okay. So about half of you are using Angular. That's good. So we're not going to dig too much into individual technical decisions. We're going to mostly discuss what changes we're planning on Angular on a conceptual level, but still we're going to show some code around the end as well. So when we talk about Angular, we usually mean 3 sub-products of the whole Angular platform. We have a framework, which is Angular Core. It allows you to build your web applications. You define your components, you compose them together, you create directives, pipes, services, and so on and so forth. We also have tooling. That's the Angular CLI, Angular DevTools. Also, we have the Angular language service, which provides you completion and type checking within your templates. And we also have components. This is our implementation of material design. We also have a CDK that provides you primitives to ensure that you're building accessible applications, since at Google it's important to be compliant and to be supporting our users, no matter what their accessibility needs are. That's why accessibility is also really important for us. And across these 3 sub-product areas, we have about 25 people. I know Google sounds huge. It is big. We have 175,000 employees, but not all of them are working on Angular, unfortunately. However, we're part of a way larger ecosystem of many other teams. We have a lot of teams working on machine learning, a lot of teams working on the web, on accessibility, on web standards. So we're lucky to be able to partner in this larger ecosystem, and I would like to share more about some of our partnerships within Google and also within the external groups. But before that, I wanted to ask you, how many of you are familiar with the term JavaScript fatigue? This is a challenge that occurred. It has been part of the JavaScript ecosystem since the beginning, but it got particularly visible about 7 years ago, I think, with the LeftPath package, if you remember. This symbolizes how kind of fragile the JavaScript ecosystem could be, how just a minor change of a dependency can break your project. So are you familiar with the JavaScript fatigue? No, not everyone, okay. Well, it is out there. I just Googled it, and I saw that there are 52 million results. So people are experiencing it. And well, Angular is pretty heavily used in Google, and in Google we kind of don't want to change something on Angular and break, let's say, Google Cloud Console, so that nobody can be using Google Cloud at all, or change something and break Google Analytics. So we have quite a few checks as part of our continuous integration system. About 26 checks in total. We have a lot of unit tests for Angular I/O. We're checking we have size tracking, so we are ensuring that we don't have any regressions in terms of bundle size if we change something on Angular. We also have checks around Angular I/O and many more. But there is a really good quote by Dijkstra saying that a program testing can be a very effective way to show the presence of bugs, but it is very hopelessly inadequate for showing their absence. So even if we have 100% test coverage, we wouldn't be able to cover all the different scenarios, all the different cases, all the different ways that people are using Angular and ensure that they're all working properly. Luckily though, in Google we're using a monorepo. We call it Google 3. Where we're storing literally billions of lines of code. And luckily, Angular has access to this monorepo. So there is one check right here called Google internal tests. So every time when someone pushes code to Angular on GitHub, let's say someone opens a pull request, we're taking this change, Angular with this change, and synchronizing it in our internal monorepo. To ensure that we are not breaking any of the existing over 3,000 applications, we are running end-to-end tests and just pretty much the test suites of all these different applications. These are literally hundreds of thousands of tests. And there are a lot of interesting technical details on how this happens, just with running everything in parallel with Bazel, using a lot of distributed computing. But just pretty much my goal here is to show that all these partnerships guarantee that we are maintaining certain level of stability. And if we break something, we need to fix it. We're not going to ask Google Clouds to stop building cloud features and go and fix Angular for us. So thanks to this, we also have the ng update experience. If we break something in Angular, we're trying to automate the transition by using a cold mod. We're creating a cold mod. We're embedding this in the Angular CLI so that when we have new version of Angular, developers can run ng updates and keep up to date with the framework and the evolving APIs. So that was the first part of the partnerships I wanted to talk about. It's kind of like a broad area, but well, we're testing Angular against 30 million lines of code or so we're pretty confident when we make a change that we're not going to break anyone. Another thing is partnership with Chrome. Are you familiar with the initiative of Chrome Aurora by any chance? Anyone? Okay, one person. I'm going to share a little bit more about it. So Chrome is, well, a web browser and also a pretty big organization within Google. Chrome's goal is to make the web platform successful, which means that developers need to be building applications that are serving their end users. So to make the web platform successful, the web applications need to be successful. That's why Chrome created a set of user-centric metrics called Core Web Vitals. Anyone heard about Core Web Vitals? All right, a couple of more folks. Well, Core Web Vitals is a set of user-centric metrics, as I mentioned, that try to put a number on the experience that your web application provides to users. There is the largest contentful paint, now we have NIP, we have cumulative layout shift, and many others. And to support developers to build good web applications, Chrome created the initiative Aurora that aims to support different framework authors, for example, Angular, React, and Vue, to support developers in building good applications according to Core Web Vitals. We have been working with Chrome, and we'll be working even closer next year, on a couple of optimizations around build time. So at build time, we'll be inlining critical resources so that your users don't have to download resources, and they'll be instead inlines within the HTML. We are also working very closely with them on improvements in our server-side rendering pipeline. I'm going to stop on this even further in a little bit. And finally, we have a very highly optimized image directive that aims to make sure that your applications are not regressing in terms of largest contentful paint and cumulative layout shift. Let me just show you how it works. So when you have an image similar to this one here, let's say a cat, you're specifying width and height. If you would like to apply the image directive so that it can verify that you're following best practices and recommend you practices that you have not incorporated in your application, you just need to replace the SRC attributes to ng-SRC. From there, since we have dynamic scoping thanks to ng modules, you will be able to take advantage of the directive, and it is going to give you the hints on what you should be doing to increase your core web vitals. We released it as part of version 14.2 in developer preview, so you can use it today. And for some partners, for example, Land's End, we saw 75% improvement of their largest contentful paint. The largest contentful paint is like the biggest piece of content that gets rendered in your website. Often that is an image. It is stable in version 15 that we're releasing in 2 weeks, and we're also planning to include a couple of more features. Automatic generation of SRC sets, so that you can generate SRC sets so that you download the minimal image, the smallest image that is going to match the dimensions that you request, and also experimental fill mode. As you saw, we had to specify width and height, and that's not super exciting for every single image on your page. Sometimes you don't know what the width and height is. It is dependent on the parent container. So the experimental fill mode allows you to dynamically take advantage of the parent container instead. Another improvement that we're working on is better server-side rendering pipeline. I am just curious, how many of you are familiar with the concept of hydration when it comes down to server-side rendering? Okay, a couple of you. What about, there is a new concept that is getting a lot of traction on social media right now with Minko and Builder.io about resumability. Resumability, anyone? Cool, yeah. It's a really cool technique. And there is actually going to be a talk about resumability right after this one, I think in the other track from one of the Builder.io's team members, who is going to share way more about it. It's a really interesting concept, so I recommend you to go check his talk. So in Angular, currently, we're performing something called kind of destructive hydration. When you server-side render your application, and we deliver the HTML to the client, once the browser downloads Angular, we destroy everything and we re-render the application from scratch, which is not very optimal, really. So in 2023, we're exploring to introduce proper hydration. We're just going to traverse the existing HTML structure and attach event listeners and create data structures. We will be also exploring partial hydration and resumability, though. And these are all really interesting approaches with their trade-offs. I would just like to show you on a high level how you can think about them by looking at this Angular application. That's pretty much shows very well my design skills. So we have a weather widget on the left of the page. We have a form with some details in the middle, and we have user profile on the right. Let's say we want to update the user profile. When we click on it, we would have to send something to the server, and we'll have to eventually update the user profile on the right. So in a traditional application, you would have to have all the JavaScript responsible for this entire page. With partial hydration or resumability, I'm currently mixing them together, even though they're pretty different concepts. But for the purpose of this example, we can allow ourselves to do that. You're going to download the minimum amount of JavaScript that is responsible for handling this action. Let's say you click on the button, we're going to download app and the form, and also the user service that is responsible for sending the updated user information. From there, you're also going to download the profile component because you have to update the user profile data. Eventually, the user profile details, and also formatter, let's say, that formats some user data. And this is all going to download only the minimum amount of JavaScript required for handling this interaction. As you can see, we didn't have to touch the weather widget, we didn't have to touch the user avatar because we didn't update it at all. That's a really efficient way, I would say, to download the minimum amount of JavaScript. However, at the same time, you may hit a waterfall situation where you need to download all these scripts one after another. And clicking on the submit button may take longer compared to a traditional application using hydration. That's why we may want to introduce something like prefetching. Prefetching is a pretty powerful concept. We can download what we assume that is going to be needed in the future. In fact, I worked on a similar project back in 2018. I applied for a talk. So I was interested in machine learning, and I'm also interested in web development. So I was thinking, well, I can apply for a talk that uses machine learning to optimize web applications. We can look into the web application, predict where the user is going to go next so that we can prefetch resources. And this all sounded really exciting. I didn't expect my talk to be approved, but it ended up being approved. So I had to actually build this thing that I promised that I already have. This is the so-called conference-driven development. Something like test-driven development, but more stressful. The time for my talk came, and well, we had to implement this thing. And it ended up working fine. However, luckily, when I joined Google, the TensorFlow team, they sit one floor under me, and we were able to come together and brainstorm with their expertise in machine learning and our expertise in web development, how we can make this work with better precision. Another experiment that we ran was introducing machine learning to the JavaScript toolchain through using Google Analytics data that we later pipe to BigQuery. And based on this, we create a TensorFlow model that we convert to TensorFlow.js and finally create a service worker that predicts where the user is going to go next so that we can prefetch resources ahead of time. You can have a look at how we exactly implemented this on the link at the bottom of the slide, but we saw significant improvements. This is not officially a product of Angular, but we have a use case, and we have a case study of how we can achieve it. So if you're interested in this, and you have use case for it, please talk to me after the talk. I'd love to explore how we can make your experience better there. Once you have this optimized application, you have to deploy it somehow. We have been working with Firebase on their FireStack initiative, where they have Firebase CLI being framework aware. So when you run Firebase deploy within an Angular project, you'll be able to deploy your client-side application, your server-side application, server-side rendering application, or your pre-rendered application, or a mixture between the two, hybrid rendering. We are also in a close partnership with clouds to ensure that these deployments scale, and they're using compute on demand with Cloud Functions and Cloud Run. And also, as you can imagine, security is pretty important in this whole story. We want to make sure that we don't have any security vulnerabilities that users can exploit. For example, cross-site scripting is a very common challenge in client-side applications. So that's why we're partnering with some security teams within Google as well on the open source software vulnerability report program. Angular is one of the flagship projects, so if you find a security vulnerability in Angular, you can make up to $31,000. So if you find something, feel free to review the guidance there at the bottom of the slide, report it, and just keep a year of work, maybe. All right. So in this process of building your application using Angular CLI, you usually have to run the ng-build command. Currently, when we're building your app, we're using Webpack. We bundle everything together, and after that, we pass it for minification to a very highly optimized tool implemented in Go called ESBuild. Once we pass everything, we minify everything with ESBuild, we're passing it to Tensor, which is a JavaScript minifier that performs more advanced optimizations. For example, it can mango your input better. And finally, we combine everything into one file, or however many lazy loader chunks you have. However, we have been getting a lot of requests from the community that people want to use tools such as Vite. That's why we talked to Evan Yu, and we tried to, who is the creator of Vite and also of Vue. We tried to figure out how we can use Vite efficiently in an Angular application, even though we don't have a single file compilation model, similar to, let's say, Svelte and Vue. During this exploration, we figured out that we can replace this whole compilation pipeline with just a single tool. We can replace Webpack with Tensor, and Tensor with ESBuild. That enables you to build even faster with certain trade-offs. Your output will be slightly bigger. With some early tests, we saw that this way the code builds will be about 75% faster, and we're planning to introduce also ng-serve mode for this in version 15. So if you want to give this builder a try in Angular version 14 or later, you can just go to your angular.json file and update the builder from the browser builder to the ESBuild browser builder. All right. So these were some of the improvements that we did in collaboration with other teams at Google. Now I would like to share more about some of the improvements we did in collaboration with the community. In Angular, we have been historically trying to be an opinionated platform, trying to offer like a horizontal solution that enables you to do end-to-end testing, linting, unit testing, and way more. And also, we kind of went down a very thin ice where we tried to implement everything ourselves. We have testing tools such as Protractor and Karma. We had the linter. We had even layout solution. So now we are trying a new strategy because we noticed that the ecosystem moved forward and many developers started using other solutions, such as Cypress rather than Protractor, for instance. Now we're trying to meet developers where they are. We're still providing an opinionated solution. However, we allow you to pick the tools that you need while still following best practices. The first step in this process was when the Palantir team deprecated TSLint. We worked with James Henry from the community and implemented a plugin for ESLint that you can directly take advantage of, directly from your Angular CLI by running nglint. To replace Protractor, we also worked with Cypress, Nightwatch, and with WebDriver IO. So now if you have a new Angular project and you want to run your end-to-end tests, you're going to get this prompt where you can select the tool you want to use. From there, you can select it, it's going to get installed, and you'll be able to run directly tests with it. We're maintaining very close partnerships with both Cypress, with the WebDriver folks, and with Nightwatch, and we're also expanding with Puppeteer and Playwright. So if these are your favorite testing tools, they will be soon available as well. All right, so actually how we decided to do that. We decided to do that by reading the feedback that we received from the developer satisfaction survey that folks are filling for us every year. We get about 25,000 responses, so this gives us a pretty good overview of what developers need from Angular. Recently we saw that debugging was #1 area that could use some improvements. So we dug deeper into the challenges that people face, and we saw that error messages are pretty confusing. As you see, more than half of this pie chart is occupied with error messages. We also have change detection, which could be a little bit magical. When change detection works in Angular, it's great, but when it doesn't work, it's not very clear what is actually going on in your application. And we also have dependency injection, which allows you to create testable code, but sometimes could be also tricky to figure out where all your dependencies are coming from. So we ran 2 initiatives. The first one was to identify top errors in the framework. After we identified them, we assigned unique error codes, and we created guides for each one of these error messages. So now when you hit, let's say, expression has changed after it has been checked, you're going to get the unique link. When you click on this link, you can preview the guides on Angular IO. And if you want to learn more about this error in a more visual way, you can have a look at the video that we developed in partnership with Fireship.io. So that was part of the story. However, we want to also improve the debugging experience for change detection. So we developed Angular DevTools. With DevTools, you can open Chrome DevTools and start profiling your application and preview each individual change detection cycle as it occurs. So if you have a couple of hundreds of change detection cycles, you'll be able to preview every one of them and see which are the slowest components in the execution. Originally, we released DevTools for Chrome, and it automatically supported Edge as well. However, we got a lot of feature requests for Safari and for Firefox. The support for Firefox we released in version 14, and Apple reached out to us to work together on supporting them in expanding their DevTools plugin API. We just gave them their requirements, and they implemented this for us. So as of 2 months ago, I guess, you can use DevTools in Safari as well. You can have a look at the docs here at the bottom of the slides. This already provides decent value. However, we still don't have the tools for dependency injection. Especially, it's not clear what are your components' dependencies, or what are the dependencies of these dependencies, or where all these dependencies are coming from, since we have this huge injector tree, and it's not really clear where you declare to your providers. So luckily, Angular is an opinionated solution. We provide dependency injection as part of the framework rather than through a third-party package, and we can figure out, well, what are the APIs that we need to use in order to preview these dependencies. We can make some assumptions about your application. So we're currently working on better debugging capabilities for change detection as well. If you click on a component in the Component Explorer, you'll be able to preview all of its dependencies, plus where these dependencies are coming from which provider exactly. For a more holistic view, you can also explore all the injectors in your injector tree and what are the providers declared within these injectors. This is still in a developer preview, so if you want to give it a try and provide us with early feedback, you can check this link here at the bottom right of the slides. All right, that's it about debugging tooling. I don't know if you remember, but there was a lot of confusion around error messages. And we really don't believe that with a couple of guides we resolved this confusion. So we talked to Chrome DevTools, and we decided to figure out a solution that would allow to improve stack traces across Angular and other technologies as well. Because really Angular and the rest of the JavaScript ecosystem, we often have pretty much the same requirements. So let's see how confusing an error happening in this component could be. Here we have a submit button where we set a flag to true, the loading flag. After that, we send a request, and we set the loading flag to false after that. And if you hit an error somewhere in this component, you're going to get a stack trace similar to this one here, which is very not clear to me what is going on in it, even though I'm working on Angular. I just see a single call frame that is coming from Angular itself, from my application, the app component, yes. If I want to expand this stack trace to get the structured stack trace, I get something even more confusing. Just look at this thing here. All the different call frames are coming from either Angular Core, Zone.js, or RxJS. After we iterated for quite a bit on the error messages, now things changed to something more like this, where you're getting the execution path from the moment when your application bootstraps all the way until you hit the actual exception. So this is something that we achieved in 3 different steps. First, this is the original error message, which is pretty confusing. What we did was to make it relevant. So from the Angular CLI, we are updating the source maps of all the dependencies, all the JavaScript files coming from Node modules, and instructing Chrome DevTools to hide the call frames coming from these dependencies. So making the stack trace relevant. After that, together with Chrome DevTools, we developed a tool called, an API called async stack tagging that allows you to take the stack traces from different asynchronous tasks, macro tasks, and micro tasks, and stitch them together. So this way we can trace the execution from clicking the button to invoking submit, sending the request, sending fetch, and after that hitting the error in our app component. And something that we are working on right now, and for which we'll have to collaborate with the TypeScript team, is improving the source maps so that everything can become friendlier as well. This is still coming up soon. Excuse me, need a sip of water. This is coming up soon. We'll have to continue collaborating with TypeScript to enable some source map APIs, but it is going to enable you to replace this final piece of generated code with the actual code coming from the template. And the best thing is that this is not a hack. It kind of works with Chrome DevTools out of the box. When you're stepping into execution, you're not going to go into Zone.js or the Angular framework. You'll be staying within your application. And it shows the proper stack trace here in the call stack. All right, so that is everything I had for partnerships. Now I would like to talk a little bit more about some of the changes we have been making on the framework side. Recently, we started asking ourselves like, what really is the heart of Angular, what Angular is. We started doing design review for the past about 10 years since the concept of like Angular framework existed. Back then it was AngularJS, now it is just Angular. And if you haven't checked this talk by Jeremy and Alex from my team, I would recommend you to do that. They go in depth in different decisions around change detection, component model, template altering formats, and much more. So we were really attached, let's say, to decorators in classes, or to classes for a way for you to create components, or to the change detection, the way Angular works. But well, we figured out there are a couple of things that are true to Angular. The first one is best practices. We really want to enable this holistic developer experience so that Angular comes with testing tools so that you can easily mock your dependencies rather than have to rely on dirty JavaScript monkey patching. Also, stability and security. Security is from a really high importance, and stability as well, since we don't want to break you after every other release. We want to make sure that we ship Angular and new features in incremental steps. And community. Like, we wouldn't be able to provide all the tools and all the resources in the world unless we have a community that is helping us with this. So one of the questions we started asking ourselves is, are ng modules actually Angular? Actually, how many of you are familiar with the concept of ng modules? All right. OK, most of you. For those of you who are not, here is a very brief overview. We have two components here. We have app and navigation. So in Angular, there is no way really for the framework to know that this nav tag within the template of the app component is associated with the nav component from the top. If that was JSX, we would have just directly imported the nav component and added it within the app components like view. But for Angular, there is really no way, because this is just a template. This is just an HTML. We need to somehow create this mapping somewhere. And we do that with an ng module. We have this app module, which declares both the app component and the navigation. And this way, when Angular sees that there is a nav within the app, it instantiates the nav component. So this is an additional concept that people need to learn. It is definitely provides some level of flexibility, because if you want to use different navigation, you can just create a different module and provide the second navigation. And you would not have to update your app component at all. It's flexible, but for beginners to Angular, it introduces a conceptual overhead. You have to learn about components and ng modules now, and JavaScript modules, and what is the difference between all these two different things. So about exactly a month after I joined the Angular team, I tried to make ng modules optional. That was something that I was really excited about, and it didn't work. Back then, we were rewriting the framework. We were moving to Ivy. And finally, after actually 4 years now, we're updating Angular to make ng modules optional via standalone components. The way standalone components work now is move the declaration of nav, rather than in an ng module, directly within your app components. I have omitted here one flag, the standalone flag to true, for simplicity, but that's pretty much the new syntax. Standalone components enable us to make this ng module concept optional, but also enable us to implement a brand new strategy for code reuse. The second most popular issue on the Angular issue tracker was the ability to add host elements to component declarations. You know, that's pretty confusing if you have not been using Angular, and even if you have. So let me share with you what this actually means. We have our map menu component, and we can use it in the following way, just applying the map menu by using the elements, the corresponding elements declare as selector. If you want to enhance this map menu, we have a couple of different ways to do that. Probably the most popular way that developers use is by inheritance. We can inherit from the CDK menu. If you want to add more functionality, which is reusable across different components, we can, well, maybe try to add one more class to the extend clause, but that's not possible because TypeScript doesn't support, like JavaScript in general, doesn't support multiple inheritance. So there are different ways we can approach the situation. We can use mix-ins. However, mix-ins will be very much focused on reusing individual features rather than reusing primitives for development of like UI components. For instance, we wouldn't be able to reuse the individual inputs and outputs and have the same semantic that they do have in Angular. Luckily though, in Angular we have a compiler, so we can provide a custom domain-specific language that allows us to reuse these components directly by declaring them within the host directives property in the component. This is the so-called directive composition API, and it is available in version 15. It is something that, thanks to the Angular compiler, enables semantics that is, I would say, more powerful than multiple inheritance because it doesn't have the same issues with it. Other questions that we started asking ourselves is Zone.js Angular? Do we really have to have like a global handler, global trigger of change detection? Or can we make it more local? We started revisiting what triggers change detection. Can we trigger it manually, for instance? And how to detect change detection happening. Something that we have been exploring with is implementations of signals. There are going to be some interesting changes coming to change detection in 2023, and I'll just recommend you to follow us on social media and our blog for updates. We're for sure going to follow up with an RFC before we move forward with it. And just to give you clues about a couple of other things that we're exploring. Are templates really Angular, or are there more efficient ways for us to develop UI components? JSX is a great example. Svelte, for instance, has a different approach with their single file components. Are classes Angular? We see a trend going to functions. So should we be using classes all the time? All these questions, I mean, will be gradually moving and evolving Angular. We're not going to break anything in the way, and we'll be running a lot of RFCs, but make sure you fill the developer survey that we're going to release in a couple of weeks so that we can hear your thoughts about it. Yeah, if you're interested in more resources about Angular, make sure you follow us on Twitter or follow us on our YouTube channel, where we're posting regularly content where we try to teach you how to be using Angular more efficiently and posting new updates. And also our blog. So as a recap, some of the things that is going to be our focus for the next couple of years. Enabling performance by default. This is the main goal of our partnership with the Aurora team. Improving developer experience across the board, starting with simplification of the framework, with optional ng modules, revisiting our altering format, revisiting our change detection, and also making the CLI just smarter and leveraging the ecosystem in the meantime so that we can meet developers where they actually are. Well, that's everything I had for you today. I'll be happy to answer the questions you have. I'm not sure what is the right way for you to be asking questions. Maybe you need a mic or? Where is it? Oh, okay, there is a microphone right there. So I guess whoever wants to ask questions should go there. Okay. Yeah, please raise your hand if you have any questions about Angular. Okay, one question.
Thank you for the talk. It was very interesting. Do you see standalone components to be the de facto standard from now on to be creating components in Angular?
Yeah, so we would like to see how people are using standalone components. Something that we're going to be working on now is kind of more statistic. So we'll be analyzing the application with the Angular compiler and collecting a bunch of statistics on the features that people use. And whoever has opted into the telemetry will be sending this to our analytics so that we can analyze how many people are using standalone components and what is the success rate. We'll be also continuing chatting with developers and seeing how they feel about it. And eventually, if the general sentiment is that most people are using standalone components, we're going to make ng modules. We're going to write migration, let's say, from ng modules to standalone components. That works in most scenarios. Any other questions? Anyone else? Okay. Well, I'll be also available right here in the next 10 minutes until the next speaker comes. So thank you so much for participating, coming to the talk.